In problem 7, g of x is going to equal 2x cubed minus 5x squared minus 22x minus 15. And the first step is to list all of the possible rational zeros. Now the rational zero theorem says that if there are any rational zeros, they should be a fraction. The numerator of that fraction is going to be a factor of this constant term, the 15. So we have to list all of the factors of 15. And that could be 1, or 3, or 5, or 15. Now the thing about it is it could be positive 1 or negative 1. So for every single number that we list, we also have to make sure that we put plus or minus in front of every number. It might seem tedious at first, but it is very necessary. The second part of the rational zero theorem says that the denominator has to be a factor of the leading coefficient. So factors of 2 are plus or minus 1 or plus or minus 2. Now the way we've listed it out is a nice way to organize our thoughts initially, but it's not a list of possible rational zeros. What we have to do is actually list them out as actual numbers. So I'm going to go through and let the denominator of every term in the numerator be 1. So 1 divided by 1 is 1, and we'll have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. That's when the denominator is 1. Now we'll go through the entire list again and let the denominator be 2. Then we'll have plus or minus 1 half, 3 halves, 5 halves, or 15 halves. Now it might look like a pretty daunting list, but remember a couple things. First of all, initially, without the rational zero theorem, we have infinitely many numbers to try. So cutting it down from infinitely many down to 16 is a significant reduction. The second thing to remember is we're not going to have to try every single one of these. Of course, I'm going to make a polynomial that has rational zeros. So we will be able to find one. The other thing is, I promise I'm going to try and make it so that the zeros that will work are going to happen at the beginning of the list. So don't be silly and start bouncing around this entire list. You want to go in order. All right? And by going in order, I mean dividing each one of these out. So using synthetic division. That means we have to go back and take all the coefficients, 2, -5, -22, and -15, and start dividing. So I'm going to go through the list and first start with just positive 1. So we bring down the 2, multiply and add, multiply and add. What we're going to multiply is 2 times 1, that makes 2, and add it to -5. 2 plus -5 is -3. So we're going to multiply and add again. -3 times 1 is -3. -3 plus -22 is -25. Then our last term, when we take -25 times 1, we get -25. Adding it to -15, -25 plus -15 is -40. Since this last term, the remainder, is not equal to 0, that means that 1 is not a zero of g of x. So we skip it and move along our list. You shouldn't move to 3, you should do -1 next. So again, bring down the 2, and we'll multiply and add, multiply and add. Multiplying those two together, we get -2. -2 plus -5 is -7. Now we multiply together -7 and -1 to get 7. 7 plus -22 is -15. Then -15 and -1 is +15. +15 plus -15 makes 0. And so there, now we have a remainder that is 0. So g of x has a 0 at -1. If -1 is a 0, x plus 1 is a factor. The other factor is going to come from these three coefficients, 2x squared minus 7x minus 15. And now it's up to us to factor this quadratic by hand. So I'm going to keep this x plus 1 outside and factor the quadratic by factoring 2x squared into 2x and x. And we have to factor 15. We start trying maybe 3 and 5 and just check. On the outsides we have 10. On the insides we have 3. 10 and 3 can definitely make negative 7 if we have negative 10 plus 3. Now, since we can't factor any of these binomials anymore, g of x is factored completely. And it's easy to identify the zeros because if x plus 1 equals 0, x would be negative 1. If 2x plus 3 equals 0, x would be negative 3 halves. And if x minus 5 equals 0, then x would be positive 5.